Okay, here we are given the three functions z, x, and y. Z is basically a function of two variables x and y. That is, z equals natural logarithm of 3x squared plus y. And both x and y are functions of t. That is, x is given as 2t and y is given as negative t squared. And we have to determine this derivative dz by dt. So let's see how to determine this derivative dz by dt using the chain rule. So first, I'm going to construct a tree diagram since we deal with three functions. So first, I put this z variable. This is a function of two variables, that is x and y. So I can put the tree diagram as it is branching like two branches, one for x and one for y. And from x, since it is function of just one variable t, I can put this as it is branching to only one branch t, and similarly y is branching to only one branch t, and since y is a function of one variable, so we have to determine this dz by dt, and here we have to find partial derivative of z with respect to x. And here in this branch, we have to find the partial derivative of z with respect to y, that is dz by dy. And here we have to find the derivative of x with respect to t, since it's just a function of one variable. So I can put this as dx over dt, and then after the y, since it branches to only one function or one variable, we have to find dy by dt. And using the chain rule, we can now write down dz by dt, and this equals product of these two derivatives. The one first one is a partial derivative, that is partial derivative of z with respect to x times the derivative of x with respect to t, plus we take this branch, that is we have to find the product of this as well as this. So it is a partial derivative of z with respect to y times the derivative of y. This is basically the derivative, it's not a negative quantity, so I'm just removing that. So it is derivative of y with respect to time. So this is the formula which we are going to use to find the partial derivative of z with respect to t. So first, we will find the partial derivative of z with respect to x as well as with respect to y. I'm going to first to find the partial derivative of z with respect to y. So I write down partial derivative of z with respect to x, and this equals, since it is a natural logarithm function, derivative of a natural logarithm function is 1 over the function, that is the inside part. So I write down 1 over 3x squared plus y, and then we have to apply the chain rule to find the derivative of this expression, that is the inside part. The derivative of the inside part, since it is a partial derivative, we find the partial derivative of the inside expression with respect to x. So when we do that, we get the derivative of 3x squared is 3 times of 2x, which is 6x, and the derivative of y, which is a constant, is 0. So this is basically the partial derivative of z with respect to x. Now we will find the partial derivative of z with respect to y, and this equals 1 over. Once again, we apply the derivative formula for natural logarithm, which is 1 over the inside part. So I write down 1 over 3x squared plus y times the partial derivative of the inside expression. That is, the partial derivative of 3x squared plus y with respect to y is just 1. So we have found the partial derivatives. Now we will find the derivative of x with respect to t as well as y with respect to t. So I'm going to find the derivative of x with respect to t. So I can write down this as dx over dt, and this equals, we find the derivative of 2t with respect to t. So this is 2. And similarly, we'll find the derivative of y with respect to t. So I write down dy by dt, and this equals, when we apply the power rule, we get negative 2t. So now we can replace these values into the formula. So it's basically the product of these two plus the product of these two quantities. So let's write down dz by dt, that is the derivative of z with respect to t, and this equals, we have to find this product. That is, we have 6x over 3x squared plus y times dx by dt is 2 plus partial derivative of z with respect to y is 1 over 3x squared plus y, and then times this 1 is negative 2t. So I write down negative 2t. Now we will simplify this. So in the first term we have 6x times 2 is 12x divided by 3x squared plus y, and in the second term we have negative 2t divided by 3x squared plus y. As we can observe, we can factor the 1 over 3x squared plus y. So I'm going to factor that. So I write down 1 over 3x squared plus y. And when I factor this from the two terms, I will get 12x minus 2t. And notice that we can replace 2t in terms of x as given in the original function. So I can replace 2t by x. So therefore this becomes 1 over 3x squared plus y times of 12x minus x. 12x minus x is 11x. So this simplifies to 11x over 3x squared plus y. So this is the derivative of z with respect to t. So this equals, this is dz over dt. Let's do part B. Here we have to determine this derivative, that is a derivative of w with respect to t. So first let's observe the three function. When we observe the function w, we see that it's a function of three variables. So I'm going to construct the tree diagram as it is a branching to three branches. So we have x, y, and z. This is z. And x, y, and z, these are just functions of t. So they just branch to only to t. So I can put this as t. Now to find this derivative, that is dw by dt, we have to first find the partial derivative of w with respect to x, y, and z. So I wrote down partial derivative of w with respect to x, partial derivative of w with respect to y, partial derivative of w with respect to z, and then after x, since these are functions of only t, we just have to find the derivative of x with respect to t, and similarly dy by dt here, and also dz by dt here. And so we can write down the formula, that is dw by dt using the chain rule, and this equals, we have to find the corresponding products and add them together. We have to find the product of these two, add with the product of these two, as plus add with the product of these two. So therefore we can write down the formula as partial derivative of w with respect to x times dx by dt, that is the derivative of x with respect to t, plus partial derivative of w with respect to y times dy by dt, plus partial derivative of w with respect to z times dz by dt, that is the derivative of z with respect to t. So this is the formula which we are going to utilize to find dw by dt. Okay, so first we will find the partial derivative of w with respect to x as well as y and z. So first I'm going to find the partial derivative of w with respect to x. So I write down this partial derivative of w with respect to x, and when we do that, we have to treat the y and z as constant. So therefore we will get only 2x, because y and z are constant, they become 0. And similarly we can find the partial derivative of w with respect to y, and when we do that, the x and z terms are constant, so we will get only 2y. And similarly we will find the partial derivative of w with respect to z, and when you do that, x and y are constant, so they become 0, and the derivative of z square is 2z. So we found the partial derivative of w with respect to x, y, and z. Now we'll find the derivative of x, y, and z with respect to t. So first, let me copy the x. So we have x equals e power 2t cos 2t. We'll find its derivative. Here we have to apply the product rule. Since it is a product of two functions, e power 2t and cos 2t, we will apply the product rule. So first I write down dx by dt, and this equals, I can consider this as first, and I can consider this as a second term. So first I find the derivative of the first term, that is the derivative of e power 2t. Here we have to apply the chain rule. So first we find the derivative of the exponential expression, which is e power 2t, and then find the derivative of 2t by applying the chain rule, which is 2. So this is basically 2e raised to the power of 2t. So I put this here, 2e raised to the power of 2t times the second function we write down as it is, and then we put plus. Now we write the first function as it is, that is e power 2t, then product with the derivative of cos 2t. So once again we have to apply the chain rule here. First we find the derivative of the outer function, which is cos function, and this is a negative sign, and then we put this 2t, and then multiply this with the derivative of the 2t, which is 2, by applying the chain rule. So this basically is negative 2 sine 2t, which I will put here. This is negative 2 sine 2t. This is the derivative of cos 2t. So let's simplify this. This equals 2e power 2t cos 2t minus 2e power 2t sine 2t. This is basically dx over dt. We will now find dy over dt. So let me copy the y, which is e power 2t sine 2t. Y equals e power 2t sine 2t. Once again, I can consider this one as first, and the second is sine 2t. So we have to find the derivative of y with respect to t. So we have to apply the product rule. First, I find the derivative of e power 2t, and this is 2e raised to the power of 2t by applying the chain rule, and then multiply with the second term, that is sine 2t, plus we write the first one as it is, that is e raised to the power of 2t, then multiply with the derivative of sine 2t, and this is going to be 2 times of cos 2t. When we apply the chain rule, we will get like this. So this simplifies to 2 e power 2t sine 2t plus 2 e power 2t cos 2t, and this is dy by dt. Now we will find dz by dt by derivating the z with respect to t. So we have z equals e raised to the power of 4t. So this gives dz by dt. This is the derivative of z with respect to t, and this equals, we have 4e power 4t. So this is obtained by doing the chain rule. So now that we have found the derivative of x, y, and z with respect to t, we can substitute into the formula, that is into this formula, to get dw by dt. So first let's do that. So I'm going to write down d, this is derivative of w with respect to t, and this equals, the first term is partial derivative of w with respect to x. So I have to consider this as the first term. And then the second term is the derivative of x with respect to t. So then I have to consider this term. So I have to find the product of these two terms, which is 2x times This gives 2x times dx over dt is 2 e power 2t cos 2t, 2 e power 2t cos 2t minus 2 e power 2t sin 2t, 2 e power 2t sin 2t plus, now I have to consider the other product, that is partial derivative of w with respect to y. So this is this product or as well as this term. So I have to find the product of these two terms. So I have to put plus 2y times of dy by dt is 2 e power 2t sin 2t plus 2 e power 2t cos 2t. And then I put the last product, that is partial derivative of w with respect to z, that is 2z times the this term. So it is 2z, can put this as 2z times 4 e power 4t. We can simplify this by factoring out some like terms. So I'm going to factor this e power 2t cos 2t first. So when I do that, I write down this e power 2t cos 2t, and so we have this product, that is 2x times 2 is 4x plus we have the other e power 2t cos 2t here, and this is the product of 2 as plus this 2y, so it is 4y. So when we factor this, we get like this. Now I'm going to factor e power 2t sin 2t. So here I have e power 2t sin 2t. So this is basically 2y times 2 is 4y. And once again here I have this another e power 2t sin 2t. So this is negative 2 times 2x, which is negative 4x. And finally I write the last term, that is this is 2z times 4 e power 4t, and this equals 2 times 4 is 8. So it's basically 8z e power 40. Now I'm going to make some substitutions here. Notice that e power 2t cos 2t as well as e power 2t sin 2t, this can be replaced from the original functions, because e power 2t cos 2t is we can replace it by x, and e power 2t sin 2t we can replace it as y. So let's do that. So therefore this becomes e power 2t cos 2t is replaced as x. So this is x times of 4x plus 4y, and e power 2t sin 2t is replaced as y. So therefore it becomes y times of 4y minus 4x plus 8z, and we can also replace this e power 4t according to the original function, it is z. So I'm going to replace that e power 4t by z. So it becomes 8z times z. Now let's do the distribution and simplify this. So I have to distribute this x into the two terms. Therefore, this becomes 4x squared plus 4xy, plus similarly, if I distribute the y, I will get 4y squared minus 4xy, and this is 8z times z is 8z squared. So now we see some common terms. We have 4xy and negative 4xy, these two gets cancelled. So finally we get 4 times of x squared, that is 4x squared plus 4y squared minus 8z squared. I'm sorry, it is positive 8z squared because we have a positive term here. Therefore, the expression 4x squared plus 4y squared plus 8z squared, this is basically the derivative dw by dt. In fact, we can also give this answer in factored form by factoring out 4 from the terms. So we can write down dw by dt. When you factor the 4 from all the terms in the expression, we get x squared plus y squared plus this should be plus 2z squared. So we can consider this also as another form of the answer.